Okay, so this is one more practice problem with Hardy-Weinberg because remember, Hardy-Weinberg problem, this will be your short answer on the evolution test on Thursday. So you're given this information. A population of roses consists of 350 dominant that show the dominant trait and 225 that show the recessive trait. And then they ask you for several different things. All right, so the first thing that you need to understand, you will be provided with the Hardy-Weinberg equations here on the right, p squared plus 2pq plus q squared equals 1, p plus q equals 1, and you are told that the p represents the frequency of the dominant allele, how common little b is in the population, and q is the frequency of the recessive allele, sorry, that's big B, how common little b is in the population. So that information is provided for you. What you're not told, and you must know, is that p squared is the frequency of homozygous dominant, big B, 2pq is the frequency of heterozygous, and q squared is the frequency of recessive. Remember, the word frequency does not give you any clues about which thing you're solving for. A frequency is just a decimal. When you multiply a frequency times 100, you get a percent. So this piece of these little things right here, this is going to be your key. Technically, I have never once seen where you had to actually plug numbers into this Hardy-Weinberg formula. But you must know what the variables stand for. Okay, so that taken care of, here's the first thing you need to know. Since 350 show the dominant trait, that does not help us because that would include p squared, all the dominant one, homozygous dominant, and all the heterozygous. So we cannot use that information because that 350 represents two things. But recessive, 225 show the recessive trait. That's little b, little b. So from that 225, we can get q squared. Now, how do you get the frequency of q squared when you're given numbers? The frequency is going to be 225 over the total in the population. So in other words, 350 plus 225, which is a total of 575. Turn that into a decimal by dividing it out, and we get that q squared is 0.39. And I do happen to be rounding to the hundredths place. You don't have to. There will be an acceptable range of answers. Now, that's q squared, not q, because q squared is homozygous recessive, or showing the recessive trait. In fact, all of these are showing the trait. So you're only being given p or q if they say something about the frequency of the gene or the allele. If they use those words, then they're giving you p or q. If they say anything about showing the dominant or recessive trait or being heterozygous, then they're referring to these other ones, the p squared, 2pq, q squared. Okay, so to get p, it's going to be the square root, q is going to be the square root of q squared, which is going to give us 0.63. To get p plus q equals 1, this formula you'll use almost every single time. The fact that p plus q equals 1. So 1 minus 0.63 will give us p, which is 0.37. So that's the first part of this question, was to determine p and q. So here's p, here's q. Okay, second part of the question, how many roses would you expect to be homozygous dominant? Okay, this goes back to the part that you have to know. Remember that homozygous dominant is p squared. Well, we have p, so 0.37 squared is going to give us p squared, and that is 0.14. But that's p squared. That's not how many roses. So 0.14 times the total number in our population, and it is always the total in the population that you're going to multiply by for this, not just the dominant ones, very important, is going to give us how many we would expect. And you would be told to round to the nearest whole number, which would give us about 81. And then finally, they want to know how many roses will be heterozygous. So remember, heterozygous is 2pq. That's the frequency of heterozygous. So that's 2 times 0.63 times 0.37, which gives us 0.47. And again, if they just asked for 2pq, that would be your answer. But they ask how many roses would be heterozygous. So you multiply that times the total number of roses in the population, and you get approximately 270. So those are your other two answers. Now technically you can see that because of rounding, in theory if you did this right, if I add those two numbers together, I should get 350 because that's how many showed the dominant trait. So that would consist of all my homozygous and my heterozygous. However, you'll notice mine adds to 351 and that's because of rounding. So if you get slightly different answers, if you got 80 and 270 or 81 and 269, because of rounding things, that's not a problem. All right? And again, please, if they ask you about frequency, the word frequency does not tell you what they're asking for. A frequency is just a decimal. For example, here the frequency of P was 0.37. If they say what percent is P, then you'd multiply by 100, it would be 37%. Or if they said what percent of the roses are homozygous dominant, we said that the frequency of homozygous dominant was 14 or 0.14, so that would be 14%. And likewise, if they give you a percent, you have to change it to a frequency to plug it in. In other words, if I said I was going to give you 10% of my money, you wouldn't multiply my money times 10, because that would be more money than I have. You would multiply it by 0.10, which would be the frequency. So percents need to be divided by 100 to get frequencies. And frequencies would need to be multiplied by 100 to get percents. If you want another practice problem on this, you can look at the homework assignment, which has a key posted. Number 5 on the homework, A through C, are modeled after this same question. So that would be another place that you could look to practice, and then the key is there. You could check your answers and see that you were doing these correctly.